It's STEAM time! Welcome back to the Maker STEAM Club with STEAM House. I'm Godiva. Let's make something together. So, for today, we are going to be exploring electricity by building a very simple RGB circuit. So you may have wondered, how do lights light up? And that goes back to the flow of electricity. So we're going to be trying a very small demonstration today to build our very own RGB circuit. So here are some of the parts that you need: a breadboard, a red LED, a green LED, a blue LED, a 1K ohm resistor, a switch, and 3 wires in red, black, and white. Last but not least, we'll power our circuit with our very own battery pack. So, depending on the components that you have, we may need to sometimes connect wires so that they can actually go into our breadboard. So here we have our switch, and we'll be connecting these wires that we've just cut on the leads that are coming from our switch. So it's very simple. Go ahead and slot it through these holes and twist our wires. And our switch is ready. So before we connect our LEDs and resistors and switches on our breadboard, we first need to identify the positive lead and the negative lead. And there's a little trick that we should all know when it comes to using these parts. Positive lead on your LED is actually the longer leg here, while the negative lead is the shorter leg here. So we'll be connecting the positive lead of one LED to the negative lead of the next. So here we have it, RGB. Now that we have our LEDs in place, we need to put in our 1K ohm resistor. Now the resistor is what you call a passive component, while our LEDs are active. Passive components, they have no negative or positive side. So we can go ahead and we are still going to put this resistor towards the positive leg of our red LED before connecting our switch. Now we'll take one leg of our switch and we will place it in the same slot as our resistor, and the other lead of our switch will connect to what will be the positive side of our breadboard. So now that we have our switch in on our positive rail, we're going to put another wire, now our black wire, on our negative rail. So starting from the negative lead of our blue LED, we're connecting our black wire straight into the negative rail of our breadboard. We're almost there. Last but not least, we'll connect our power pack. Using convention, red is for positive, so we'll take the red lead of our battery pack and connect it to the positive rail of our breadboard. And we have black, which is ground or negative, and we'll take our black wire and we will go ahead and connect it to the negative rail of our breadboard. Now, here is the real test. Will we have all our LEDs in our RGB circuit actually light up? Let's see. There we have it, our very own series circuit for RGB colors. So far, we've been exploring electricity with our series circuit. But what is electricity? Electricity is a type of energy that we use to power many things in our daily lives. It's a form of energy that's generated by the movement of very tiny particles called electrons. These electrons move through wires, circuits, creating electrical currents that can then be used to power our lights, TVs, computers, and many other devices. Electricity can also be found in nature, like in light bulbs and electric eels, but is also generated in power plants and delivered directly to our homes and schools through power lines. Understanding how electricity works is important for knowing how we can use electricity safely and responsibly. And we should also know about electricity so we can help to make our world more sustainable by using renewable sources of energy. So, what really is a circuit? A circuit is a path that allows electricity to flow from one point to another, and it includes our wires, our batteries, or switches, and other components like our LED. Now, let's demonstrate how electricity flows in a closed circuit. So here we have our battery. We have two lines, power and ground. And in order for electricity to flow in a closed circuit, we have to connect our power to our resistor and our ground to the negative lead of our LED. And there we have a closed circuit that allows electricity to flow through it. But if we open our circuit, our light goes off. So remember, it's always important to ensure that you have a closed circuit in order for electricity to flow. There are two ways in which we can connect our circuits: series and parallel. A series circuit has components connected end to end, similar to how we have it here. First our red LED, then our green LED, then our blue LED. But for our parallel circuits, we have our components connected side by side. So here we have our red LED just beside our green LED, and last but not least, our blue LED, all connected in the same line. When we look at our series circuit, we realize that our components are wired one after the other. First, coming from our power source, we have our switch, then we have our resistor, followed by our red LED, green LED, and last but not least, our blue LED before going right back to power. It is important that we understand that electricity has to pass through one component before it goes to the next. When things are wired in parallel, they are wired side by side such that electricity passes through all of them at the same time from one common point to another common point. Here, we're going to be building our RGB circuit, but this time in parallel. Now, for our parallel circuit, there's one important part that we really need to not forget, and that's the fact that all of our resistors have to be connected in the same time. Hence, why for a parallel circuit, we have one common point. This common point will be line 1 on our breadboard. So here, we'll connect all three resistors in line 1. Now, we'll go ahead and start connecting our LEDs. But remember, we insert the positive leg of the LED first. Red LED. Next up, we have our green LED. And last but not least, our blue LED. There we have it. Now there's one last step, and that is putting in our very own switch. We'll use our switch and have it also connected to that common point where all our resistors are tied, which is line 1. And now we're just about ready to have everything go to ground. Now let's see what will happen when we power this up. There we have it, all three LEDs now connected in parallel. Now, a fun thing about parallel circuits is that we get to direct electricity exactly where we want it. Here, we have a common point, but we have 3 lines. So now we've added 3 LEDs, 3 switches instead of 1, which means now we can go ahead and turn on our red LED separate from our green LED separate from our blue LED. And if we want to have them all turned on, we just flick our 3 switches. So there you have it, your series and parallel circuit. So next, we're going to be exploring light and sound in parallel circuits. Comment below and let us know what you want us to make